Hey, this is Joe, Graybench Electronics. Welcome back to the bench. So this week I wanted to check out one of the tube amplifiers that I converted for guitar amp use. This is a Pathfinder by the Newcomb company. Specifically, this model is the E-20 model. They made a bunch of different Pathfinders with different output tube combinations for different output wattage. The E-20 here is a nice middle ground. It's two push-pull EL84s or 6 BQ5s for about 15 watts or so, not dissimilar from like an AC15. The Newcomb Pathfinder amps were designed for like public address use. They have inputs for microphones and phono inputs for like a tape or a record player. On the front we have 5 controls. The treble control is also the power on switch, so when you start to turn, it clicks the power on. Bass control, phono is the phono input volume, mic 1 and mic 2. There are 1/4 inch input jacks for mic 1 and mic 2 over here. The treble and bass controls are wired in reverse from what we're used to, meaning when you turn up the treble control, you're actually cutting the high end, and as you roll it back down, it gets brighter. Same for the bass control. When you roll it counterclockwise, it gets fatter, and then when you roll it to the clockwise direction, it gets thinner. I've done a couple modifications to this. Generally, these amps don't require a lot of modification, just putting on a 1/4 inch jack if it was RCA jacks or whatever, and maybe a little bit of tweak to the frequency response or tonal characteristic of the amp to make it more appropriate for guitar use, and then these things are generally good to go. There was one mod I made that I will show inside, but another mod I made here on the front is removing this phono jack and installing a master volume. It can be a bit deceptive because of how high output guitar amps tend to go, but 15 watts is a lot. It's a very loud amp, and there was essentially no ability to drive the circuit in here with the volume without getting pretty loud. And so a master volume is exactly for that purpose, is to be able to drive the preamp of the amplifier but have the overall output volume still manageable, I guess. So I removed the phono output and the associated circuitry. We'll look at the schematic in a second. And I installed a standard post-phase inverter master volume that just blends together the two grid connections of the push-pull output section in order to get phase cancellation, which will effectively act like a master volume. And that'll make more sense when we look at the schematic. On the back here, we have our captive power cable. This was a replacement from the original. I believe it had a 2-prong cable, so that had to get swapped out for one with a safety ground. On the back, the output jack here was an RCA. That was replaced for a 1/4 inch, so standard like guitar speaker cables can be used. The output transformer selection here, the impedance selection for the output connection, is done via a little spade connector and screw terminals. So this output transformer had a bunch of options, which was common on PA tube amps back in the day. You have a 4 ohm output, a 0 ohm, which is just your common or connected to ground, 8 ohm, 16 ohm, and 25 volt, which is sort of a PA specific thing. Phono jack, RCA jack is connected to nothing because we removed that control for the master volume. These speaker jacks are, I think they're still in circuit, but they're not being used for anything. There is an AC outlet here that's just in parallel to the input voltage. So if you had your turntable on here that's connected to your phono output, you could power it just into here and not have to run 2 cables to your wall outlets. There's also a small hum balance pot that just controls the amount of resistance either side of the filament winding sees to ground, which can battle hum. I picked up the Pathfinder here, and I guess I'm making this video now to give a shout out to Uncle Doug, who was inspirational to me in getting started working on tube amplifiers. Uncle Doug specifically makes tube amps really approachable, and his videos gave me the confidence to start working on my own tube amps. I know for me, the anxiety of working on tube amps was difficult to overcome, but watching his videos and the way he explains things, I highly recommend his video series on how tube amps work. It just gave me the confidence and the willingness to go and get started in there, and the belief that I could do so safely. I will say, even to this day, when I work on tube amps, I still get nervous, and I don't know if I want to get rid of that completely, because I think that nervousness or anxiety can keep you on your toes and keep you from getting cocky or lazy. I'm happy to say now that I've built over a dozen tube amps, I've worked on more than that, and I still haven't shocked myself, and that's a record I'd like to keep going. And I attribute my success being that I didn't have any traditional education. You know, I didn't do an internship with some other tube repair person. I didn't go to school for electronics or electrical engineering. So I contribute my success to the guidance of people like Uncle Doug, and also like Carlson's lab, Mr. Carlson's lab, giving me the knowledge about the equipment, the confidence to believe that I could do it, that my ignorance or my anxiety wasn't going to stop me or actually cause me to mess up. Uncle Doug has a video, I think it's about 10 years old now, converting one of these Newcomb Pathfinder amplifiers. So I wanted to walk the same path and follow along in his footsteps, doing a conversion of one of the Newcomb Pathfinders. So yeah, shout out to Uncle Doug. Thanks for the great videos. And if you haven't checked out his channel, I'll put a link in the description. He makes great videos, and especially for anyone looking to get into working on modifying or building tube amplifiers, definitely a channel to check out. Let's have a look underneath the shield here. So the amp's sort of in two pieces here. This upper piece is just sort of a shield or a cover that's made out of just stamped sheet metal. It has these nice cuts in the top called louvers that help dissipate heat out from the amplifier. The lower chassis is its own piece of metal that has all the electronics inside. The top cover here is connected with a couple of screws. It also has these nice stamped handles so you can easily pick up the amp and move it around. Let's go ahead and have a look inside. So you can see at some point somebody must have dropped some liquid and they came in here and rusted up the enclosure a bit. It's not a big deal, it's really just aesthetic differences. It's funny, in Uncle Doug's video, he actually repainted this top cover here a nice like surf green color. And he referenced the original sort of ugly pea green color. That's this color here, which I agree is not the most pleasing color. But I'm not interested in repainting this right now. I would want to at least get the rust off of here, which would take some work. So we're going to leave it in the ugly green color for the time being. Underneath, we have the electronic components. These are replacement 6 BQ5s from JJ. They are a match set. I think Apex did the matching on those. We have our power transformer, our output transformer, 2 preamp tubes. In the V1 position is a 12AX7. This is actually a Sylvania 12AX7. That's in V1, so that's doing the preamplifying for the mic inputs. And then next to the circuit V2 is the 6BR8. 6BR8 is a half pentode, half triode. So that's doing amplification after the tone controls, and the triode is doing the phase conversion. It's a paraphase phase inverter, or like a concertina phase inverter, some people call those. 2 shields for those. The rectifier is a Sylvania 5Y3 GT. I forgot to mention, these are not the original knobs. I replaced these with these nice vintage Bakelite knobs, which I think work very well. The original knobs are sort of plasticky, and they stuck out really far from the enclosure because they had these little plastic setting reminder pieces. So these would be underneath the knob, and you would turn this to your preferred position. And then when you turned off the amp, you could move your knob, and if you wanted to set it all back to where you had it last, you could just move the knob back to wherever you set this position. The downside of these is that the knob one stuck out pretty far because I had to have room for this to move underneath. And they were just kind of plasticky. I think the ones on it were kind of beat up and dirty too. So I just swapped it out for these knobs. And I think these were a nice fit. You can clearly see the graphics and they just look right for the amp. Something about new knobs just give an amp aesthetically like a new life, a new vibe. Can capacitor back here, this is a replacement from CE Manufacturing with the, I think it's the same values, maybe a little bit higher voltage rating. These red pieces over here are covers for the input jacks. They're standard octal sockets, just like you would see for power tubes on other guitar amplifiers, or these are octal sockets. However, some input transformers, they usually look like little cans, will be used for microphones that needed to have their impedance matched to the circuit. In this case, we're plugging in high impedance guitar pickups, so that's not an issue. Underneath, there's a little jumper that needs to be made, a connection made, so that the input jacks can feed into the tubes. That jumper lives underneath these little caps. That'll make more sense when we look at the schematic. So let me prop this up and we'll flip it over, have a look inside. All right, so here's the inside of the Newcomb Pathfinder. Again, this is the E-20 version, so it uses 2 of the 6BQ5 or EL84 output tubes. You can see it's all wired in a pretty standard point-to-point connection method, very common back in the day before circuit boards were widely used. I didn't do much modification to it because it doesn't really need it. The one modification that I added in is what I'm going to call the Uncle Doug mod. That's essentially putting a 15 microfarad cap here across the cathode resistor for the pentode of the 6BR8. We'll look at that some more when we look at the schematic, but yeah, that's the one capacitor, and that changes the frequency response of the amp to be more appropriate for guitars. Like I said, it doesn't take a lot for these amplifiers to be totally usable and very comfortable in a lineup for guitar use as opposed to microphones as they were originally intended. You can also see this orange and yellow wire coming across here. This wasn't original. That is connecting to the 2 grids of the output tubes and coming over here to that middle potentiometer, which is the phono or at least was the phono volume, but is now the master control. So this is just a variable resistor between the two grids of the output tubes. Will work as a master volume because you are connecting the grids of the output tubes that will be out of phase from the phase inverter. When the two out of phase signals come together, they phase cancel. When you put a greater resistance between them by turning up this, by turning up this phono connection, you're putting more resistance between the two connections, which stops that phase cancellation from happening and increases the output volume. I did replace the coupling caps for the output tubes. These are very important capacitors because if these start to leak, then you will have excessive current flowing through the tubes, so that could destroy output tubes. So replacing these coupling caps, I think, are very important. The original capacitors, as far as I remember, I wasn't seeing any excessive voltage on the grids, or it was sitting right around 0 volts, but it's just one of those safety things that I think is just a good idea to do for older vintage amps so that you don't roast your output tubes. These are 630 volt film capacitors. They'll last a very long time. So that's one mod that I made. The phono input had a bunch of components sitting in here associated with its connections. That was eliminated. There was a ground bus wire that was coming across here that are replaced with just standard wire. Still trying to maintain the same ground connections that were originally connected with that phono potentiometer, but those had to be removed for the master volume control. The CAN capacitor was replaced. That's the multi-section capacitor down there. Again, just one of those things. I don't recall if it was leaking or if there was bad hump with the original amp. I did this a little while ago, but replacing that is just, I think, a good idea. The CAN capacitor sees a lot of voltage, the maximum voltage the amp puts out, and provides all the high voltage for the amplifier. Replacing that will protect your tubes, protect your transformers. So that got replaced. You could still find, as I did, new manufacturing high voltage CAN capacitors, so it was an easy swap. If you have an eagle eye and are spotting those solder joints and thinking to yourself, they don't look that great, you're correct. My soldering iron didn't have the necessary heat in order to get the chassis hot enough to make a good solder connection. They're okay. They're strong enough. They're not like wiggling or disconnecting or anything, and there's not any noise, but I do need to get a stronger soldering iron to actually make a good connection for those. So that is on the list of to-dos for this amp, which is pretty short. It sounds great the way it is. So the large 10 watt resistor here is the cathode resistor for the power tubes. It is a cathode biased amp, which means that the cathode is lifted above ground with a resistor, this one here, and then the grid is negative with respect to the cathode. That is what allows you to control the signal coming into the grid on the power tubes for amplification. If that didn't make sense, go check out Uncle Doug's video on how tube amps work and it will become more clear. The original amplifier, I think, had a 150 ohm cathode resistor. This got bumped up to 240 ohms for two reasons. One, because modern wall voltages are usually in the low 120s, at least here in Southeast PA. The amplifier originally would have been designed for around 117 volts back in the 60s. Second reason is because it's interesting, the chassis here and the tube itself is a 5Y3 GT rectifier tube. However, the schematic and the voltages associated show voltages for a 5Y3 or 5Y3G, which has a greater voltage drop when it's rectifying. Had the 150 ohms stayed in here, the tubes would have been biased at like 150% plate dissipation. It's not uncommon to push 6BQ5s really hard. If you don't believe me, go look at some matchless guitar amps and you'll see. But 150% plate dissipation, I think, is just asking to kill power tubes. So I increased the cathode resistor to 240 ohms. That puts it just a hair above 100% plate dissipation. The downside, or the thing you have to be careful, is as you reduce the current through the tube, you're necessarily going to increase the voltage. That's just Ohm's law. And so the plate voltages are sitting higher than they are on the schematic. Even on the schematic, they were already exceeding the max voltage for 6BQ5s. They're now sitting around 400 volts. We're going to put some power and you'll see all these voltages, but the design parameters for 6BQ5 or EL84s regularly get abused, both in like plate voltage and plate dissipation. I try to find a happy medium where we're just pushing the dissipation a little bit. The plate voltages, yeah, they're in excess of the rated 300 volts, but lots of people do that, so it is what it is. Here is the power switch treble control right there. Not much to see on this end, but it is switching these two connections here, which is what turns the amp on. There's a neon bulb in the corner here for indication and a little dropping resistor or current limiting resistor for the bulb. Here is the safety ground connection on its own solder lug coming off the output transformer here. I do usually prefer it to be on its own hole, completely separate. Like if this hardware were to grow loose, then potentially your safety ground would be compromised, but I didn't want to put extra holes in the amplifier, and this was convenient. I did put a locking nut on top, so there's now two nuts on this stud. They're long enough, and so pretty unlikely this is going to come loose, but of course, as you should do anytime you're working on an amp, good idea to check hardware is tight. but especially that one. The 18K resistor in the power supply that was replaced with a metal oxide flameproof resistor down there. There was some work done in here to set up this 1/4-inch jack for the output as opposed to the RCA. Replaced the spade cable here for making different connections on the output transformer. That got replaced. But I left most of the amplifier intact. The resistors here, they all tested fine. The carbon comp resistors, the input capacitors, the 20 nanofarad input caps, these ceramic pieces here, coupling caps, those all are the same. We'll look at it on the schematic, but the output transformer is unique for this amplifier. It's an ultralinear output transformer, so it has independent taps for the screen connections on the output tubes. The most common place I see this is on Sun amps because they were built originally off the Dynaco tube amp kits. But yeah, this has an ultralinear output transformer as well. So yeah, that's pretty much it for the inside. Let's have a quick look at the schematic and I'll point out the things that I did inside. All right, so here's the schematic for the E20 from Newcomb. I've made some amendments to the schematic based on the changes that I made. So the first thing I wanted to talk about was the 5Y3/5Y3 GT discrepancy. The voltages definitely indicate a use of a 5Y3, which is written on the schematic. It's showing 360 volts at the plate, which if you plugged in a 5Y3, an actual 5Y3, not GT, that is the voltages you would probably end up getting at 117 volts on the input. I've never seen one of these amplifiers with a actual 5Y3 in it. In fact, I've never seen a 5Y3 that would fit in this amplifier. I've only seen the 5Y3Gs that have the larger like soda bottle glass, which don't fit underneath the metal lid for the amplifier. So I'm not sure, which version of this was able to have that, or if there is like a 5Y3 in a smaller package. I've never seen one, so I'm not sure. The amp definitely has a 5Y3. The voltages are definitely higher, so that's one thing to be aware of if you're working on one of these amps, is to watch your voltages, especially if you're going to increase the cathode resistor like we talked about, because that's you're going to push your plate voltages even higher. So there is the 150 ohm cathode resistor. It's now 240 ohm. Here is that master control. You can see it's coming up here to the grid of one tube and to the other side the grid of the second power tube. And it's just a variable resistor in there, 1 meg resistor, audio 1 meg. As you increase the resistance here, there's less phase cancellation because there's a greater resistance. At full volume, it's essentially like the pot isn't there. But when you wind it down, you're essentially shorting the two grids together, which will phase cancel because you're taking taps off this triode, and the plate and cathode will be about 180 degrees out of phase. So if you combine those together, you get a phase cancellation, you get nothing. Here is the Uncle Doug mod, what I'm calling the Uncle Doug mod. 50 microfarad cap coming off the cathode of the pentode amplification stage. And yes, it's going to increase the gain out of the stage. It's going to increase the bass response. And I first saw this in Uncle Doug's video, so I'm attributing it to him. All these parts here are removed for the phono control to make room for the master volume. The two mic inputs, they're identical. I have seen someone do another conversion of this where they put a bypass capacitor around the volume control. I don't think it's necessary. This amp is pretty bright as it is, so having that bright channel, it seems like it would be excessive to me. If anything, I'd want to tame the high end of this amp, so that's not something I'm going to do. So the inputs are identical. They are a grid leak bias setup, so you have a large resistor to ground from the grid on each stage, and then a input capacitor. So the electrons will accumulate on the grid. They won't escape through the 10 meg because it's a very high resistance, and they won't escape through the capacitor, which is an open circuit for DC. So those electrons will essentially bias the tube by creating a negative field around the grid, controlling the flow of electrons. So there is your first tube, the 12AX7, that provides amplification for the two mic inputs. The 6BR8 is your pentode and your triode, pentode for amplification, triode for the phase inversion or phase splitting. Down here, this is the CAN capacitor. So this has the 4 individual CAN capacitor or capacitor sections. The original was rated 450 volts, the new one's 525, so a little bit higher voltage, which is fine because we're putting more wall voltage into it, so better to have a little bit more breathing room there. And yeah, generally it's a pretty simple amp. It's kind of unique. It's got the grid leak bias input, it's got the pentode, intermediate pentode stage, the paraphase inverter, the ultralinear output transformer. So there's not really any guitar amps that's similar to it, but it also didn't have to change that much from what it was originally as a PA amp into a guitar amp. One mod to the circuit for tonal reasons, the other really just for utility, like the master control, removing the phono, replacing the caps for longevity, durability, making cathode adjustment just to bias the output tubes, and it's a pretty solid little guitar amp. So I'm going to set it up to do some voltage readings, and you'll be able to see how the amp is operating, what voltages I got going, and then we'll finish up with a listening test. All right, so we're set up to do some voltage readings here. I have a high wattage resistor back here, 8 ohm resistor, so that'll be loading the output transformer just to make sure we don't cause any damage there. Flyback voltage. Volume's turned down, amp's plugged just straight into the wall right now, probably sitting around you know, like 121, 122 volts is typical for here. We can turn the amplifier on and we'll just clip on to, so you can see there, I believe this is the plate or the screen. This is pin 9, which should be the plate. I don't remember my pins for EL84. No, screen is sitting at 409 volts on the screen, and the plate's at 407. There's our cathode voltage across that 240 ohm resistor, 16.5 volts. So we can do our calculation. Yeah, 407 volts on the plate. We got 6PQ52. I'm using the Rob Robert S2 bias calculator. We subtract the cathode voltage, which was 16.5 volts. So that's 390.5. A 100% max dissipation for cathode bias would be 30.7 milliamps. We can then use the cathode resistor voltage drop calculator to calculate how much current is actually flowing. So we have two tubes, they're sharing cathode resistor. The voltage across is 16.5 volts. The cathode resistance is 240. So we are at 106% plate dissipation. So they're running a little bit hot, which, like I said, there are companies out there that run 6PQ5s EL84s into like the 120, 130%. If I hadn't replaced the cathode resistor, it would be at like 150%. So this, I feel like, is, I'm pushing it, but I'm not pushing it that bad. Seemingly the more concerning measurement would be the 100 or the 400 volts, which like 25 or actually 33% higher than the max voltage rating, plate voltage for EL84s is supposed to be 300 volts. But it's probably the case that like the output wattage wears on tubes more, like the dissipation wears on tubes more, because that's the heat. That's that hot element thing that's actually putting work into the tube rather than the voltage itself. As long as you don't arc, then you should be okay. I don't know if I'd be running it much higher than 400 volts because that really feels like you're pushing it. We're a little bit hot on the plate dissipation. I could increase the cathode resistor to like 250. That would probably bring it down into 100% safe dissipation levels, but like I said, people run EL84s even harder than that. So there's our bias conditions, and why don't I set up now, we'll have a listen to this thing.